Okay, now we're going to learn two more concepts that are related to line segments and lines and points. We're going to see this word a lot. It's called a bisector. A bisector, bi meaning two, okay? Bisect meaning cut into. A bisector is an object that cuts another object into two equal and smaller objects. Basically cuts it in half, okay? So a segment bisector is a bisector of a line segment. Okay, so it takes a line segment and cuts the line segment into two equal lengths, two equal line segments. So it's an object, it could be a point, it could be another line segment, it could be a ray, it could be a line. It's an object that cuts a line segment into two line segments that are of equal length. So we have this line segment JK. Goes from here to here. And this point M, okay, if we put that there, we can see here, see that when we put a little letter M here, that means measure of. The measure of the line segment JM, here to here, is 12. So from here to here is 12 units. The measure of line segment KM, that's the distance from here to here, is also 12. And so this distance is 12, and this distance is 12. So that means point M is cutting the line segment JK into two equal pieces, two pieces of 12. And therefore, point M is a segment bisector, okay? Now, what is the measure of the overall segment from J to K? To answer that question, we need the segment addition postulate. Don't worry about this word postulate. It just means it's true, okay? So very simply, the segment addition postulate says that the sum of two line segments, JM and KM, the sum of two line segments is, that means equals, the length of the overall segment that's made up of both line segments. So JK, line segment JK is made up of line segment JM and line segment KM, and therefore the measure of JK is equal to the measure of JM, which is 12, plus the measure of KM, which is 12. So the overall measure of JK is going to be 24, 12 plus 12. That is the segment addition postulate. Okay? I'd like to do a few more examples of this segment addition postulate. All right, so we have here line segment AG. And there are several points on line segment AG. We have points A, B, C, D, E, F, and G. Okay? And these numbers represent the measures of the interims. So line segment AB has a length of 7, line segment BC has a length of 5, etc. Okay? And what we want to know here is we want to know the measure of line segment AD. So A starts here and it goes to D here. Now note that these measures, these line segments, they have to be consecutive. You can't do a portion here and then a portion over here. You have to do the whole thing in between. And so we want to know the distance from here to here. Well, all we have to do is add up AB plus BC plus CD. So we have three segments. It's going to be the measure of AB plus the measure of BC plus the measure of line segment, I should be saying line segment here, CD, which is 7 plus 5 plus 8, which is 20. Okay? So the measure of line segment AD by the segment addition postulate is 20. Okay? All right, well, what is the measure of line segment CG? That goes from here to here. Well, it'll be 8 plus 3 plus 9 plus 4. And so that's 11 plus 9 is 20 plus 4 is 24. And so the measure of line segment CG is going to be 24. And now we want the measure of the whole line segment from A up to G. Well, now we just have to add up all of the values. 7 plus 5, that's 12. 12 plus 8 is 20. 20 plus 3 is 23. 23 plus 9 is 32. 32 plus 4 is 36. And so the measure of the entire line segment by the segment addition postulate is 36. Okay? And that's it for the segment bisector, bisectors, and the segment addition postulate.